Hello and a big warm welcome. My name is Andrew Mallett and I am the Urban Penguin. In today's video, we're going to take a look at UMask, our first dive into the Linux file mode, or what you probably call the file permissions. Now, what we really want is an easy life and, well, is there such a thing as zero-touch administration? Well, we're going to find by adjusting the UMask, we need to set our permissions less often because we can adjust the defaults so they really work for us. That seems something worth looking into, doesn't it? And hello and a big warm welcome to the command line, a command line of my Alma 8 system, a Red Hat clone. I've logged in as a standard user. This is a Vagrant virtual machine, and you can see from my user account name there, I've logged in as Vagrant, and I'm currently in my home directory. Or on LS, you can see I don't have too much in my directory at the moment. I'm going to begin by creating myself a directory to work with. I'm just going to call it play. So mkdir play, and then cd. Don't forget we can use the escape and dot. Escape and dot recalls the previous argument. So just a little shortcut that we can get used to using. And of course, now we've got a clean and empty directory to work with. And we're going to be taking a look at the UMask, the user file mask in Linux. Using our UMask, we can set a value to adjust our default permissions. I always begin when we're looking at our Linux mode or the file permissions by looking at the UMask so we can get a good understanding of what the defaults are and how we can adjust the defaults. So if I clear my screen, so Control and L, if I look at my current UMask value, the default UMask value that we have in Red Hat Linux system is a value of 2. And we're going to be looking in more detail of exactly what that means for us. For the moment, we can just put that to the back of our minds and look at what happens when I create a new file. So if I go through and touch file 1, we can then go through an ls-l on escape and dot. We can see then that we've got read-write, read-write, and read. Read-write is assigned to the user Vagrant. The middle 3 bits of our permission or mode are the permissions that are granted to the group. Here, again, we've got read and write being granted to the group Vagrant. Many Linux systems implement a private group scheme, so we can see then to avoid assigning too many permissions to a shared group, Vagrant is a private group just for our user. And then we've got read for others. The last 3 bits of the permissions represent others. And it's important wording. We're not just playing with words. We're saying other than the group or the user. It's really important and very important to understand that in Linux, file permissions are not cumulative. They don't add together. I first of all searched the user ID. If I match on the user ID, then I can pick up the user permissions. If I match on the user ID, I don't even check the group permissions. So as soon as I've hit a match, I don't go beyond that. If I don't match on the user ID, then I can check my group ID. If I belong to one of the groups listed in the group, so here it checks to see if I'm a member of the Vagrant group, if that's one of my groups, and I don't match on the user ID, then I can pick up permissions granted to the group. But I only check the group permissions if I haven't matched on the user ID. Permissions are not cumulative. And then it's the same in that third block. I only check the permissions granted to others if I haven't matched on the group or the user. So something very important to take with you, however much you might want the permissions to be cumulative, they aren't cumulative. When I create a directory, the same thing applies. Permissions aren't cumulative. But let's take a look with mkdir and then dir1. If I run ls-l, we'll look at the complete directory now. We can see the permissions on the directory and the file are not the same. A file does not get execute by default, and that's by design. Whereas having execute on a directory allows me to enter the directory. So it does default to giving the execute permission to a directory. When we look at it, the user has read, write, and execute. The group has read, write, and execute. And others have read and execute. We can see in both the file and the directory that we're missing out on the write permission for others. When we look at read, read would have an equivalent value in numerics as 4. Write would be 2. And execute, X for execute, would have a value of 1. If they're all set, then we would have a value of 7 in an octal format. When we look at our umask, it's still there at the top of the screen. It hasn't gone anywhere. In that last and final block, we've got a value of 2. Having a value of 2 represents write. In the last block, it's for others. The umask is removing the write permission from others. The true defaults, let's clear this line so I can use Control and U. The true defaults are 777 on a directory, 666, or the sign of the devil for a file. Read, write, and execute all of the way through on a directory, read and write all of the way through on a file. The umask is used to adjust the defaults. And the reason why we want to adjust those defaults is pretty much because we don't want to do all of the work. We would like Linux to do some of the work for us, some of the heavy lifting. And why shouldn't it? I would say the umask command is very similar to the cd command. And you're going to say, nah, Andrew, I think you've lost it. It's nothing like the cd command. Well, I'm going to ask you then, why do you use the cd command? Well, the answer is probably because you're going to be moving to a directory because you want to work with a heap of files in that directory. Am I right? Of course, there is no need to move to a directory. You can use the absolute path to the file, but it's going to be longer and involves more typing. So for ease and speed, we move to the directory. And it's the same thing really with the umask. Just like cd, it's only affecting your current shell, no other shell that you might have open. If I change my umask on the shell, it's not changing the default value of the umask. In the same way, if I change a directory in my shell, it doesn't change that to my default directory when I log in. So there's an awful lot of similarity. To show you what I mean, if I clear the screen, if I want a whole load of files to be private, I can set my umask value in my current shell to be 077. So we're not removing anything from the user, and we're removing all permissions from the group and others. I can hit enter on that. And now if I go through and touch file, we set a whole load of files. So let's use our brace expansion, and we can then have files 10 through to 19. And then go through and close off my brace brackets. As I look at these, we can see then it's read and write just to the user. so private to the user account. And this would be the same if I created a directory. We're removing all permissions from the group and others with a umask value of 77. Well, okay, now having created those files that I needed to be private, maybe now I want to share with the group. But maybe the group should only have read access through to the file. So I set my umask to be 27. The umask can only remove permissions. We can never add permissions to the defaults. So I can never make a file executable by default. But by setting the umask to 27, we're removing the write permission from the group, and we're removing all permissions from others. When I then go through and touch my files again, it's only new files this is going to have an effect on. So I'm going to have maybe 20 through to 29. And then run my ls-l again. When we look at those new files, we can see from 20 through to 29, the group now has the read permission. And I haven't had to change the permissions on these files at all. We can now allow the defaults to work for us. If I like this umask, and I'd like this then implemented when I log in, I can set it as my default umask value. If I clear my screen, and then just go through and find my home directory, and moving into the .bash rc file, we should be able to then go through and edit. Uppercase G moves to the end of the file, lowercase o inserts a new line, and I can then go through and set my umask just as we do on the command line. So I'm going to set it to 027, escape, colon, and X to save and exit. We can check that that is working if I log out and then log back in again. The bashrc file or .bashrc file runs every time I log in. So it will have executed now. And of course, when I look at my umask value, it's got a value of 27. Now, really, to see the absolute value and zero-touch administration behind a umask, we need to set ourselves up a shared directory. If I currently look at the groups that I belong to, so using the id command, you can see that the Vagrant user belongs to the wheel group. Now, maybe we want to create then a directory that can be shared to the wheel group, but should be private to the user and the group. So again, my umask kind of works a little bit for this, but we can set up the directory with absolute permissions when we create it. We're going to create the shared directory in our root file system. So we're going to do this with sudo. Let's clear the screen just so it's easier to see what I'm typing. And we're going to go through then and run our mkdir command. We can set the mode. We can set the permissions when we create it. This means then that we're no longer using the default permissions and we won't actually be applying our umask when we create the directory. I'm going to set the permissions and then we'll talk about them. And I'm going to create the directory shared. So /shared. When we look at the permissions, if we concentrate on 3770, that's the mode or the permissions that we are setting. We've used 4 numbers where you might be more used to 3 numbers. Looking at just the last 3 numbers, 7 is read, write, and execute for the user owner. The middle 7 represents read, write, and execute for the group owner. And 0, of course, is no permissions being set for others. When we look at the value 3, that's our special permissions. That includes the value 2 and 1. 2 would be for the set group ID bit, 1 for the sticky bit. The set group ID bit ensures all new content in the directory will be group owned by the group owner of the directory. So that's really good as far as our zero-touch administration is concerned. All new content in the directory are going to be group owned by the group owner of the directory. The sticky bit, or the value of 1, controls deletions from the directory. The group has read, write, and execute. If we can write to a directory, we can delete from the directory. We don't want the group to be able to delete anything but their own files. The sticky bit set on a directory ensures that users only delete files that they own. So as I go through then and set that, when I look with ls-ld and we look at the symbolic permissions for the shared directory, we've got read, write, and execute for our user, read, write, and set user ID. It's lowercase, so execute is already set. For the group currently is root. Remember, the group special bit, when set on a directory, ensures all new content is going to be group owned by the group owner of the directory. So we definitely need to look at changing the group owner. We have no permissions for others, but we also display then the sticky bit in the others block. As an uppercase value, it indicates execute is not set. If it was a lowercase t, execute would be set. The sticky bit, when set on a directory, ensures that users only delete content that they own. So these are really great permissions, but to make it really work for us, if we use then sudo and change to the group owner, so chgroup, on our shared directory. Of course, I've forgotten to specify the group, but that doesn't matter. We can easily add it in. Now, as I go back and list that directory, we can see the group owner is wheel. So the wheel group has got read, write, and execute through to this directory. So we can see now this is really going to work, and this is where the magic begins. If I go through then as my user, I belong to the wheel group, I can touch /shared, file 1, or files 1, it doesn't really matter. If I use sudo and touch, we're working as root, and I can then up arrow key and then change this to, say, files 2. If I look now with a long listing, and this is where the magic is really going to be, when I look at then that shared directory, the permissions are set correctly, read, write, and read. We're not giving any permissions to others. So our security is working from the outset. The group has read, but look at the group owner. On both of these files, the group owner is not the private group vagrant or the private group root, which we've previously seen. It's the group wheel. That's controlled through our set group ID bit being configured on the shared directory. With that set, any new file created in the directory is going to be group owned by the group owner of the directory. The umask is ensuring then the permissions are correct. So if all of the users have the correct umask of 27, as content is added to this directory, then it's going to have read, write, and read for files. We'd have read, write, and execute, read, and execute if it was directories. But we don't have to worry about changing the ownership of any of these files. We don't have to worry about changing the permissions. The heavy lifting is being done by the umask and the special permissions on the directory. Which reminds me, the other special permissions that we set was controlling deletions, the sticky bit. With the sticky bit being set on a directory, we only delete files that we own. Normally, having the right permission to a directory allows you to delete anything from the directory. But we can check. If I do an rm, escape and dot, and just add in the asterisk, we're getting a warning to say, well, look, that's a write protected file. But if I say, yes, I'd love to delete it, it says, you can't. It's the sticky bit that is preventing me from deleting files that I don't own. But of course, there was no problems deleting the file that I owned. So I know this is a little bit of a long video, and I know many people like shorter videos so they can consume very quickly. But there are some subjects that we just sometimes need to spend a little bit more time on. Understanding the UMask becomes important, so we don't have to worry about changing our permissions regularly. We can have our UMask set correctly so that the file permissions are correct. But very often when we're working with shared directories, we need to make sure that the special permissions are configured on the shared directory. Here we set the group ID bit to control the ownership of new files, and we set the sticky bit to control deletions from the directory. Thank you very much for watching, and do continue to watch and subscribe. As always, add comments. Those comments we do pay attention to, and if you put in topics that you would like to be covered, then we will endeavour to cover those topics. We can't cover everything, but we will endeavour to cover some of the topics that you want to look at.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.